Buenos días niños, me alegro de verlos. Ayer no mandé este video porque ayer era día de Ancillary. Entonces ya estamos de acuerdo porque todos los lunes van a ser lunes de Ancillary con la maestra de música, con la maestra de salud, Miss Smith, con la maestra de, no sé, computer, la de educación física, de PI. Creo que son tres o cuatro, no sé bien. Pero me dijeron que el lunes usted estaba ocupado con Pi, entonces por eso no mandé. Y otra cosa que me dijeron los niños de Khan Academy, que necesitan crear un nuevo usuario ahí, y entonces yo no, eso sí no sabía yo, porque yo pensaba que eso era dentro del distrito igual como Imagine Math, que no necesita usuario. Entonces Khan Academy, ahí a los que pudieron crear el usuario, porque yo no sé cómo crear el usuario de Khan Academy. Entre los que pudieron, pues ahí yo les puse matemática de cuarto grado, porque a mí me preguntan entonces qué va a hacer ese niño, yo le puse matemática de cuarto grado. Yo creí que eso iba a entrar automático, pero no. Entonces mejor usar Imagine Math. Ahora sí, entonces, vamos a hacer esto a ver. En inglés toca hacerlo acá. The condition of the atmosphere at a certain place and time is the weather. Esta palabra, what is the weather? The condition of the atmosphere. El estado del tiempo, lo dicen en español. Tiene que saber en ambas cosas. The weather is the condition of the atmosphere. The atmosphere is the layer of gas that surrounds the earth. You make imagine the planet Earth, but around the planet Earth there is a layer of gas, a layer of air. That's the atmosphere. And the temperature and the humidity and the conditions in that layer of air is the weather. The amount of water vapor in the air is the humidity. 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 Okay. Weather, humidity. How humid something is the amount of water, the water vapor. Right now, the air that you are breathing has a lot of water. And when people, for example, put a glass of very cold, let's say with ice, with cube of ice, and small drops here on the outside the glass, that drops as the water that is in the air, around the glass, I mean, there is air, and when the water in that air cools down, condenses and forms the drops around the glass or in the window in the morning. You see in the window in the morning like a lot of water. That's water that is in the air that condenses because it's cold when the glass is cold, condenses the water and that's why you get drops of water. Okay. Number three, the weight of the atmosphere pressing down on Earth's surface is the pressure, the air pressure, air pressure, the air pressure. You have to look for those words in the book or in the video that I put. Some children told me, no, I need the video, I need the video. I don't know why you need the video. You have to enter into the hub, digital resources, use my own, use Imagine Math, and the math and science textbook is there. You read that page that you have explain what is air pressure. For example, if you are in a mountain, imagine a very high mountain. You are down here at the sea level. Let's say the sea level. Sea level. The amount, there's a lot of air on top of you. And here, down here, the air pressure is very high. You're here at the beach, at the sea level. The pressure is very high. Imagine this is a very, no, a very, very tall mountain. I cannot draw it. If this is the person is gonna be just one little dot. Very tall mountain, and you go to the top of the mountain, the pressure or the air pressure is less because there is less weight of the air on top of you. At the sea level, there is more pressure. At the top of the mountain, there is less pressure, air pressure. And people use the barometer to measure the first barometer. It was a cube that somehow the people with a pump take the air out here, and it's a vacuum here, and put it in a something like in a plate, and here a liquid, metal liquid, that's mercury, and because it's vacuum here, the what? The liquid metal, the mercury goes up, and because the air pressure is pushing down here, and the more pressure, the higher the column of the mercury. But now they I don't know, they have a device like it looks like a clock with a needle and tells you the pressure. Okay, the air pressure. A large body of air with the same temperature and humidity throughout is an air mass. Air mass. It's a large body of air. Air mass. You have to check the book. There is a like the continents, let's say North America and South America, and large masses of air. Here, close to the pole, cold air. It could be dry, it could be humid. Here, the air is warm and hot. I mean, humid because there is a lot in the ocean. So masses the air, I mean big air masses. I mean, a large body of air. The process by which a liquid changes to a gas is evaporation, from liquid to gas. Evaporation. That's a very important word for us, for graders. They are going to ask you that word in fifth grade in the test. Evaporation. You are studying this word since kindergarten, I think. The process by which a gas changes into a liquid is condensation. From a gas to a liquid is condensation. Condensation. Evaporation and condensation. Evaporation, liquid to a gas. Water that falls from clouds to Earth's surface is precipitation. 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 Let's see, precipitation. Here, precipitation. The problem here is that you cannot tell me that you cannot see because... Okay. Like in the class, I cannot see what you are writing. Oh no, because I have to put it. And sometimes I'm talking, I'm not looking at the screen. So I'm looking at the paper. But here, precipitation, you need to know that there are three classes. The rain, snow, something like that. Called sleet. I forgot the word sleet. And what's the other? Hail. Rain is water. Yeah, water. Yeah, drop of water. This one is snow. Everyone is snow. Snows the snow. And the sleet. The sleet is it's a very little. It's not snow, but it's not hail either. It's between the two. Very little drops of ice. Little drops, yeah. Little drops of ice. And the hail, yeah, so those are bigger. Bigger. It's not like a drop, but it could be very big as like an orange, they say, like a baseball. Like a baseball. Something like a pea, but like this size. Ice. Bigger drop. It's like a drop, but it's bigger than a drop. Bigger drop of ice. Oh, everyone knows the hail. Sleet, snow, and rain. So the four types of precipitation. It's very important that you know this. En inglés, la lluvia, la nieve. En inglés como que no tiene, en español como que no tiene esta palabra. Hail es granizo. Sí que le dicen lluvia nieve, ya que me acordé. Lluvia nieve. Como que le dicen lluvia nieve, sí, sí. Water that cannot soak into the ground and instead flows across the earth. Water that cannot soak into the water and instead flows across the earth is the runoff water. Runoff. Runoff. Ok, ya tenemos todas. 1, 2, 3, 4, 5, 6, 7. Armas también lo pusimos acá. Armas, ya. Ok, todas las palabras. Runoff. The rivers, lakes also, lakes. All the water that is on top of the earth. The other water goes down the ground, the earth's surface, underground water. Okay. The runoff, so the flood, when something floods, you know the inundation, the flood. Rivers, lakes, streams, kind of runoff water. Okay, let's see, hurry up. Dana measured the temperature and humidity every afternoon and for 4 days. She recorded the results in this table. Okay, here is the date, the temperature, the humidity. By analyzing her data, which day can Dana conclude was the hottest? Okay, the hottest and most humid. So the hottest here, this is 28, 27. People use Fahrenheit, but when you are in science, they use the Celsius degrees, like the metric system. 28, 27, 24, 28. So these 28 and these 28 are the hottest. But the hottest and the most humid. And this one is, the humidity is 69, so 69% of the air is water vapor. And this is 90, so this is much more humid than this one. So Monday is hotter and most humid. Sometimes in the air masses that I was talking about, if you are in the desert, the air is hot but dry. If you are close to the ocean, it can be hot and humid, like here in Houston. We are close to the ocean, close to Galveston, so that's why here is very humid. If you are close to the North Pole, it could be cold and dry, not humid, but they say dry. Okay, in the desert it's hot and dry, the air. Carl looks at the weather map and notices the following symbol. The symbol shows a warm front moving toward his town. So the air masses I was talking about, it could be a dry and hot or dry and cold, cold and humid and cold and dry. So they have a front, the front. This one is a warm, maybe, I don't know, warm and humid. It could be warm and dry. Based on the tips on this map key symbol, which prediction can Carl most likely make about the weather? You have to read. I was not able to print that. I was going to print that page, but I don't know, something happened to my printer. I cannot print now. I have to change and fix it. But I was going to print the page that they are explaining that is something here in this question. They have it here also. The question 10 is related to this one. When a mass of air, this is a warm, it says warm air, and this is cold air or cool air. So if the warm air comes, it's going to go up because it's warmer. The cold air goes down, and the warm air goes up. So see, this is they call the front. In the map, they make if you have the map, they say okay, that symbol they say like this, the like those bolitas like this. Okay. So it means the warm air is coming and the cold air is under it, and when they join together, those happen like this, and the warm goes up but start cooling down, and the water that is in the warm air here down here, no problem with the water, but it's cooling down in forms the clouds, and then the clouds is gonna rain. So when the clouds are here, the warm air gets cold and start raining. That's what so based on this map key symbol, what happened? Okay. Hold. Based on this map key symbol, which prediction can Carl most likely make about the weather? Sunny and clear skies is not, because I told you it's gonna form clouds. Cooler temperatures, not, because it's a warm front. It says shows a warm front, so it's not gonna get cooler. And changing temperatures, no, it's gonna change. The temperature anyway is gonna change. So steady and heavy rain. Yes, I told you why. When two fronts, that's when you look at the news. There's a front is coming. It could be warm, it could be cold. But as long as the two masses of Earth collide, it's gonna be a bad weather. So heavy rain. Byron wants to measure and record changes in air pressure. Which tool should he use? Okay, the barometer. Barometer is the thermometer is to measure the temperature. A weather map. A weather map shows how the masses of air, the air masses move. The weather vane. The weather vane is that shows the direction of the wind, direction of the wind, okay, or wind direction. It's like kind of narrow. It's a little like it's on a pole here, and it has like a narrow. don't know how to make an arrow, but okay, let's point it. But here it has like a tail, so the air, it has to, this one spins and shows the direction of the wind, the weather vane. Sometimes it has also here like a cups, so there's an anemometer to measure the speed of the wind. So the weather vane is the vane, it's like the arrow, and those cups are the anemometer, measure the speed of the wind. So the whole thing measures the speed and the direction of the wind. Okay. Which of the following sequences show how water may move from an ocean to land and back to an ocean? No, this is the water cycle. The water cycle. The water cycle doesn't start with the precipitation. No groundwater, no cloud formation. The water cycle is this one: evaporation first, goes up, evaporation, and here we have it here. Evaporation, here condensation, it starts to cool down, cloud formation, precipitation, runoff, and here underground water. Groundwater. So, what is the question? Up here. Evaporation, cloud formation is next. This is 1, 2, precipitation 3, runoff 4. Here. You have the picture in the next question. So 1 is evaporation. Evaporation. Then condensation. Condensation and cloud formation is the same. Cloud formation. Then precipitation. Precipitation. Here you have the number 1, 2 is 3 is this one, and 4. This is underground water. Come on, groundwater. 4, it could be, if goes here on top of the surface, is runoff. If it goes in the what looks like it, okay, this is like a runoff, river, no, runoff. I don't know if it looks like underground or not. I don't know. It could be on the surface, or if it goes underground, it makes the under the groundwater. And these are the answers. So the answer here is because it's very similar to this one. And here they are asking in which is the cycle precipitation. Precipitation is number 3. Okay, the anemometer. The anemometer is this one. I'll tell you the anemometer. This one, the one that spins according to the weather, to the air speed. Barometer is the one to use to predict. Which of the items below will help Sarah use the weather map to predict the weather? So the weather map, if you're gonna use the map, you have to use the map key. The barometer, I told you already, to measure the pressure. The satellite is like a picture. With the satellite, they make them the weather map. No, with all of this, you have to use all of this information to make the weather map. But the weather map has a key. It says for this one means cold front with some like triangles. This one means a warm front. And they have a key map that each picture says like a symbol. What is the meaning of the symbol? después de map key. This diagram illustrates the pattern of earth movement in a coastal area. Which of the wind is illustrated in this diagram? So this is the sea breeze because it's coming from the sea. Sea breeze. It's not land breeze because land breeze is when it goes from land to the sea. And this one happens because when the sun warms the earth during the day, the air here in the water gets colder. The water takes the heat, and it doesn't, but it's like kind of cool, or colder than in the air. In the land starts heating up quickly, like a stove, and the air here is gonna also get hot or warmer. And when the air gets warmer, it's going to go up. So that there's like a vacuum here, and the cold air from the ocean is gonna move this way because here is hot and goes up. Start doing like this direction. And at night it's the opposite. This one gets cold, and the water is warm. So warms the air here is warmer. The air, I mean, and it's going up, and it starts going the other way, the opposite way. This is during the day. This air is warm, goes up, and the colder air from the ocean goes this way. Sea breeze. This is they have to understand this. This is the most difficult question everyone fails. Why the air is moving this way? Because this one is warmer, and when there is warmer, it has to go up. It's less dense. You have to know about the density. The warmer something is less dense, more volume, less dense, goes up. This picture illustrates how a puddle changes over the course of a day. So this is the puddle. This is the puddle. And what is happening with the puddle? It's drying off. So what happened with the water? The water evaporated. Which process is taking place? Evaporation. Because the puddle dried off. It was big and now smaller until it disappeared. Okay, the evaporation, the change from liquid to a gas. And this is water vapor. You cannot see water vapor. You are breathing water vapor right now. In your room at this moment, half of the air is full of water. You cannot see it. So the water from the puddle, it didn't disappear. It went to the air. It converted to a gas or water vapor. The liquid became gas. Taro is studying the water cycle, I mean. He knows that energy is needed for matter to move and change state. So what we are talking here, the water heats up and dries, and when it's hot, goes to the air. What is a major source of energy for the water cycle process? So the puddle, why is the puddle drying off? Because the sun is warming is heating the puddle, or heating up the puddle. What is the source of energy? The source of energy for that process is the sun. The sun is the one that the rest of most of the energy that we need. You can have a chemical reaction that gives you energy, but the sun is the most of the time. Jerry notices that the air pressure is rising. Based on this observation, which changes in weather might Jerry record? So the pressure is rising, 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 rising. I told you when there are two masses of Earth like this one. Here the air start going up, going up. So let's make there. Let's make there. Imagine the air is going this way, and here goes this way. Here, well, I'll make an arrow here. But this is very long distance. This is not so small. This is, for example, this is the ocean, and this is the land. Here, the ocean, the air is coming this way, so the pressure, here the pressure is gonna be a little bit higher, high pressure, well, plus pressure, because the air is moving in this direction, there's a little bit more pressure, and here less pressure, less minus pressure, only P. But less pressure, what happens with the air here, the air from the ocean has water in it, it's a humid air, and it starts going up here, because the land is hotter, the sun is heating, and it heats up the land, and the land heats up the air, so the air goes up. But when the air goes up, make the clouds. But you feel here, if you're here, you feel less pressure because the air is moving up. So less pressure means that clouds are forming, and maybe it's gonna rain. And okay, rain here, and the air keep moving, let the water over there, and gets dry, and start cooling down. And when cooling down, goes down again. So the pressure is more here because the air is moving down here. So less pressure, a pressure is rising means the weather is gonna be fair. It's not gonna rain, not storming and stable, windy. Well, it could be a little bit windy, but this is one of the questions that most people fail. They don't understand what this process I'm telling you. More pressure, good weather. Low pressure, bad weather. Here I'm telling the same thing. The the air is moving up. So the water that is in there is gonna condensation, and form the clouds, and it's gonna precipitate the rain. The air is going up, and when the air is going up, you feel less pressure. Okay. This diagram illustrates a location where the two air masses meet. Which changes in weather might be recorded at this type of air boundary? Clear and cold is not gonna be clear. No, clear no. This is not the answer. Clear, because you see the clouds forming. Clear, no. Cloudy and rainy. Yes, cloudy. You see I have told you many times this why. Windy and cold, no, cloudy. Because the air here, it has water vapor. It's warm. When it goes up, it cools down. colder. So the water from here is gonna make the cloud here, and probably later on it's gonna precipitate, and you feel less pressure. No, less pressure means it's gonna rain. And over here is the pressure is rising. So on the other side, so it's not. Yeah, it rain over here, and here is not gonna rain. The water stays here. Precipitation. Okay, oceans get fresh water from precipitation and rivers. However, ocean water levels do not change very much as a result. Why are these levels not greatly appreciated? Okay, so imagine that a cup. This is the ocean. Imagine this is the ocean, and you put rain and water and rivers. A lot of water is coming to the ocean. But why the level of the ocean doesn't go up? But a lot of water is coming to the ocean, but the level is still. That means that somehow water has to go somewhere. But the problem is that the sun hits the ocean, and here there is evaporation. You cannot see the evaporation, but a lot of water is going what is becoming water vapor. So a lot of rain, a lot of rivers bring the water, but here the water stays the same because the water is going out of the ocean by the means of evaporation. Water is constantly seeping into the ocean floor, so like the water is going down. I think it's very full of water over there also. Water is constantly evaporating over the ocean surface. Yes, because water is disappearing by water vapor. Water is constantly flowing back into the rivers. How come the water is gonna go up again? No, through the river. Water is constantly deposited back on land by ocean waves. No, sometimes a tsunami happens or something, but it's not all the time that the waves, the waves go, but then the water, even the tsunami, it floods a big wave floods, destroyed the town here, but after a while the water ran off back to the ocean. The sea level doesn't rise because a lot of evaporation is forming or happening. Oh, look at this picture. Okay, here you have all the proof that I am giving the class. Hold it. Okay. This diagram illustrates the atmosphere on a day in late winter. Precipitation is falling. Which type of precipitation is likely to form in the freezing cold layers of air? Explain how you know. So this is the answer, sample answer. The sleet is likely to form. The sleet forms when raindrops fall through a layer of freezing air near the ground. So you have to go back to the page when they are explaining the precipitation, and I told you three types of precipitation: rain, snow, snow. This one is sleet. This word is sleet, and hail. Bueno, granizo. So here, this is the arrow has to go this way. This is cold air. This is warmer air. Cold air freezing the air. So the drop of water is gonna form little drop of ice called sleet. The weather map illustrates a front moving across the Midwest. Write to describe what the symbols mean. Use the weather map and weather symbols to make a prediction about the type of weather Little Rock will have. Little Rock, what is Little Rock? Little Rock is here, this top here. And this one is a cold front. A cold front is coming this way. So it's gonna be bad weather. I've already told you the answer. This is the answer. The weather symbols show a cold front moving across the Midwest. This is the Midwest, and the cold front is all of this, the mass of air. Little Rock might expect heavy rains, thunderstorms, and lower temperatures as a result. Yeah. The warm air here is gonna collide with this here. The warm air is gonna go up, and a lot of water is gonna rain. So bad weather for Little Rock here. That happens when two masses of air collide. Min uses Celsius thermometer to measure and record the temperature over a 3-day period. The temperature was 26 Celsius degrees on Monday, 20 Celsius degrees on Tuesday, and 17 Celsius degrees on Wednesday. What was the average daily temperature for the 3 days? So to make the average, I told you how to make the average when you grade. You get when you have the grade test for the tests. Okay, let me explain. 26. You add the data. 26 or what? 20 and 27. 17. 26, 20, 17. So these are the two. I mean the three temperatures. 3 pieces of data. Add 6 and 7, 13. Carry over 1. 3 and 2, 5. And 1, 6, 63. Now you have to divide by the number of data that you added. So you have 3 pieces of data, you have to divide by 3. 63 divided by 3. How many times can you subtract 3 from 6? 2 times. And here you multiply 2 times 3 is 6. 0 left here. Now you have to divide the ones. 3. How many times can you subtract 3? 1 time. 1 times 3 is 3. And 3 minus 3 is 0. So the answer is 21. So 21. How to make the average? You need to add the numbers that you are going to get the average, and they divide the sum divided by the number, how many pieces of data you add. You add 4, you have to divide by 4. If you add 5, you have to divide by 5 to get the average. Bueno, caramba, esto pues ya vamos a hacer, creo que mejor no alcanzo tengo que poner esto en el YouTube ahorita, eso sí se demora en subir al YouTube. Mejor mañana seguimos con este libro azul, ¿no? ¿Sabes cuál es el libro azul que le dije? De resolución de problemas. Algunos se los mandé por online, ya tiene que tener eso. Ya le dije, ahorita mañana empiezo a revisar ese libro y ya creo que se acaba el año con este libro. Hagan Imagine más mejor entonces, ahorita apenas se acaba el video de ciencias.